afternoon, everyone. I'm Julie Creech. I'm a current sports medicine fellow at the Military Sports Medicine Primary Care Fellowship in the DC area. And it's my privilege today to introduce Fran O'Connor as he teaches us about sickle cell trait in the warfighters and the athletes, what we know, what we don't know, and where we go from here. So just to start, this installation of the National Fellows Online Lecture Series is brought to you by the AMSSM Online Fellows Education Subcommittee, the AMSSM Education Subcommittee, and the AMSSM Fellowship Subcommittee. The purpose of this lecture is just to serve as an adjunct to your individual program's educational programming and provide fellows with direct access to educational experiences and experienced AMSSM members and sometimes invited guests in a variety of formats, and then just assist in the preparation of the CAQ examination. Some ground rules. We ask that during the lecture today, you mute your device's microphone and turn off your video. If you have any questions that arise during or after the lecture, please submit those through the chat function, and you can include your name and your program if you'd like. I'll then ask the questions to Dr. O'Connor at the end of his presentation based off of what is submitted. And then at the very end of the lecture today, if you don't mind completing the evaluation just to help evaluate this lecture and help us improve for future years. Without further ado, let me introduce Dr. Fran O'Connor, who is the current professor and medical director for the Consortium of Health and Military Performance, or the CHAMP lab at the Uniformed Services University. He has been a leader in sports medicine education and research for the military for over 30 years. Dr. O'Connor has authored over 100 peer-reviewed articles in scientific journals, and in addition, he has published numerous books, book chapters, technical reports, and health promotion resources for the military. He is the editor of 8 texts on sports medicine, including the Textbook of Running Medicine, the Sports Medicine for the Primary Care Physician, 3rd edition, and one that we are all hopefully learning pretty well, the ACSM Sports Medicine, A Comprehensive Review. He has been on the board of several leading organizations in sports medicine, including the American College of Sports Medicine, the American Medical Athletic Association, and he's past president for the AMSSM. A military academy, he graduated from the Military Academy at West Point. Prior to his current posting at the Uniformed Services University, Department of Military Medicine, he served for 1 year as the command surgeon with the Special Operations in the Middle East. Dr. O'Connor is the recipient of several awards for excellence in sports medicine research and education, including the Corey Stringer Institute's Corey Stringer Institute Life-Saving Research Award, presented by the NFL and Gatorade to him in 2012. He was also recently selected for an ACSM 2016 Citation Award, as well as AMSSM's Founder Award in 2017. He is a past chair of the Department of Military and Emergency Medicine. So now I'll turn over the screen to Dr. O'Connor so we can all listen and learn from him as he teaches us about sickle cell trait.
Thank you, Julie. Can you hear me? Give me a thumbs up. Okay, let's see if I can get my slideshow going here. There we go. Okay. So yeah, Julie, thank you very much for the introduction, and it's a privilege to be able to talk to the AMSSM membership, in particular the fellows, this afternoon. And as Julie said, we're going to be talking about sickle cell trait. More than anything, I'm really going to share with you what I don't know about sickle cell trait, and hopefully you're going to be able to answer with me or after me. I have nothing to disclose as we move forward here. As a new family physician coming right out of residency in the military, most of the time we use utilization tours before we start our fellowships. And at the time when I left my residency in 1988, I went to New Jersey to Fort Dix. Fort Dix is a very interesting post. At the time that we had about 5,000 basic trainees running around. And it's at that point I started to learn and develop as a new doctor, and I started my family. Here you see my lovely wife, Janet, and my son, who's now 6'3", Ryan. But it was at Fort Dix that I really learned a lot. I learned how to become a family doctor. and I got very interested in exertional illness. In particular, I actually had a patient of mine who was a drill sergeant who died of a sickle cell trait related collapse at a PT test in 1989. PT is a physical fitness test. And at that time, I met Dr. John Kark. Dr. John Kark was a colonel at that time in the United States Army. He came up from Walter Reed to Fort Dix, and he talked to our hospital, our medical treatment facility, about sickle cell trait, what it meant, and how we could move forward thinking about it. And I developed a relationship with Dr. Kark at that time, and I've really been interested in exertional related collapse, in particular sickle cell trait and sudden death, since that time. I'm going to flash forward 30 years, and it happens very quickly. 2019 happened to be a particularly bad year in the military, with at least 5, maybe 7 sickle cell trait related associated deaths. And this is at Great Lakes, where we train our NCOs in the Navy. And I had an opportunity to actually investigate 2 sickle cell trait associated deaths with these 2 young ladies, 18 and 20, that you see here on the right side of the screen. So this is something that I've been thinking about and working on for a long time. So in the next 45, 50 minutes, we're going to talk about sickle cell trait, just to bring you back up to speed as fellows, what it is, how it differentiates from sickle cell disease. Really going to go over what's known and unknown about sickle cell trait and exercise. We're going to talk a little bit about the screening issues. I think some of the historical background and some of the controversies you should be aware of. I'm going to describe what we're very interested in, which is exercise-associated collapse with sickle cell trait. I'm going to go over some of the practical management, some of the guidance we're putting out in the military right now, and then finally, some of the questions that remain to be answered, some of the research we're doing. So what is sickle cell trait, and how does it differentiate itself from sickle cell disease? Well, this hemoglobin molecule that you see over here on the right is pretty important and very complex. Obviously, it carries oxygen to muscles so that we can do work. But it's interesting, this complex protein, as you see here, with 4 protein subunits, 2 pairs of 2 different types of globins. We've got alpha and beta globins, each connected to this heme ring that carries oxygen. Important to know, we have 280 million molecules in each red blood cell, 280 million. We know that if you have a mutation in this beta group, that can create hemoglobin S, and that can, of course, create sickle cell disease if you get 2 copies, one from mom and dad. And if you only get one from mom and normal from dad, you're going to get sickle cell trait. It is an autosomal recessive disorder. Now, sickle cell disease, and I'm sure many of you, in particular primary care physicians, pediatricians, family physicians, have managed children and adults with sickle cell disease. It's a devastating disease. Obviously, these sickle cell shaped cells lead to anemia, which is going to limit exercise capacity, and it causes red blood cells to die prematurely, and unfortunately is associated with a shorter life expectancy. There are many medical complications that we're aware of with sickling that can occur. In particular, many of you are familiar with the painful crises that can occur, that can be excruciating for patients with sickle cell disease. Importantly, in the military, sickle cell disease is disqualifying. So we do not take people into the military with sickle cell disease. We do, on the other hand, take people with sickle cell trait. So let's talk about sickle cell trait. It's common. We're looking at about 4 million people in the United States, 300 million people in the world have sickle cell trait. And you see a large concentration here, in West Africa. And there's a reason for that, because it does provide some genetic benefit in that it helps modify or mitigate against severe complications with falciparum malaria. You look at the numbers in African Americans, it's about 1 in 10 to 12 in the United States. Hispanic Latinos about 1 in 180, and Caucasians about 1 in 625. So when you're taking a look at the United States Army, that has about 1.2 million men and women, active duty and reserve, we are going to see African Americans and Caucasians who have sickle cell trait. Now, it's important to know a little bit about some of the genetics involved with sickle cell trait. As I mentioned, it's a complex protein. We have 4 different protein subunits, 2 beta change and 2 alpha chains. We know that they're also on different chromosomes. So actually alpha is from chromosome 16, beta is from chromosome 11, and of course you got a copy from mom and a copy from dad. This one single mutation, I don't think you're going to get this on a CAQ, but one single mutation, that single nucleotide where you go from an adenine to a thymine, changes the codon or the amino acid profile, and we convert a glutamic acid to a valine, and this creates all this havoc with sickle cell disease. It's important to know, however, that this is not the only hemoglobinopathy out there. There are actually 1,100 hemoglobin variants that can occur. And this is something we're very interested in because rarely do things occur alone, as we know, and there may be different variations that occur with sickle cell trait that may confound or accentuate some of the clinical problems we see. Now, one of the things that you need to be aware of, and certainly Randy Eichner, longtime member of AMSSM, internist, hematologist, has taught us, is that alpha thalassemia and it's present with sickle cell trait may be a lifesaver. So as we look here, on my first bullet, with hemoglobin S, normally hemoglobin S, if you have sickle cell trait, it's going to be less than 1/2 of the total hemoglobin in that heterozygote. But depending on the degree of alpha thalassemia and how many copies you have of this alpha globin, that can be reduced. So it will mitigate against some of the complications that you see with sickle cell trait. In my second bullet here, you see how the percentage of hemoglobin S is reduced into the proportion of the number of active alpha genes that you have. If you have 4 normal alpha genes, it's going to be 35 to 45%, which you typically see in sickle cell trait. But if you have significant alpha thalassemia with only one healthy alpha globin gene, that'll be down to 17, 25%. So alpha thalassemia in combination with sickle cell trait is thought to be a potential lifesaver. Okay, let's transition to what we know and what we don't know. Now, back in 2010, there were 2 deaths in the United States Army and U.S. Army Training and Doctrine Command, basic trainees. And this led to General Dempsey, who was the TRADOC commander at the time, actually asking our organization to please look at these deaths, look at the science, look at the evidence, and to see if we could come up with some better guidance on management and risk stratification of those people with sickle cell trait. So we put a conference together in 2011. Some of these people you will recognize who came to this conference: Dr. John Kark, who's the colonel I described. Everyone should know Dr. Randy Eichner. And we had 2 leaders in sickle cell trait research community, Dr. Kwaku Ohene-Frimpong from CHOP and Dr. Alexis Thompson from Children's Hospital in Chicago. Dr. Thompson is actually the president of ASH. So we had a lot of people who thought differently about sickle cell trait that we brought to this conference. So what do we know? Well, first of all, the military has studied this, and this is a publication that came in MilMed in 2018 from some of my colleagues at USIS in Preventive Medicine. This is Daryl Singer and his group. And they took a look at warfighters, soldiers in particular, who were sickle cell trait positive, and compared them with African-American soldiers who were sickle cell trait negative, and found that actually these service members that were sickle cell trait positive deployed more frequently, greater lengths of time, they remained in the service longer. Their particular study, they saw no significant difference in crude mortality, and really made their bottom line up front was sickle cell trait is compatible with military service. We also know that there's a lot of literature out there on sports participation with sickle cell trait. This is one study from Legaye in 2007, taking a look in Africa, in particular on the Ivory Coast. Many of the national records on running courses less than 400 meters are held by athletes with sickle cell trait, so certainly involved in a lot of intense exercise. We also know that sickle cell trait athletes compete in the NFL, and they've competed in Mexico City at altitude successfully. One athlete you may well be familiar with is Terrell Owens, who's quite outspoken about sickle cell trait screening and sickle cell disease. And Terrell Owens is reportedly also to have sickle cell trait, obviously has gone through a number of intense workouts in his career. But we also know the literature is very strong that sickle cell trait is associated with sudden death. This was a publication in the American Journal of Medicine 2009. And it goes over here the cumulative evidence that it is associated with hematuria, not uncommon with sickle cell trait, renal papillary necrosis, hypoostenuria, and inability to concentrate your urine. It's estimated that if you have sickle cell trait by the age of 30, 35, almost everybody is hypoostenuric. Splenic infarcts, obviously worse with exertion or at altitude, exertional rhabdo, and of course, exercise-related sudden death. Here you see the faces of 9 young men with football thought to have deaths associated with sickle cell trait-related collapse. Now, it's important to understand the big picture, however, because we're all interested in preventing death as primary care sports medicine, and everybody should be familiar with this graphic from Barry Marin taking a look at at deaths in young athletes, and the majority of these being cardiovascular, and having to go all the way over here to the right to look at the other category. And that other category is where we start to pick up sickle cell trait related deaths, most of these associated with exertional rhabdomyolysis. So having this big picture in mind is very important, as we move forward with public health preventive strategies. However, I would argue, and I'm going to point out with some of the research we have done, you've got death, but then you also have rhabdo, an exertional rhabdo that can be quite severe and debilitating. So death may represent just the tip of the iceberg on complications with sickle cell trait. This is my colleague and partner, Dr. Patty Doister, and our group had a publication in the New England Journal of Medicine back in 2016 looking at sickle cell trait and exertional rhabdo. And you'll see our bottom line up front here is that sickle cell trait was not associated with a higher risk of death in the cohort we looked at than the absence of trait, but it was associated with a significantly higher risk of exertional rhabdo. So we clearly have clarified this increased risk. Interestingly enough, this increased risk in African Americans with sickle cell trait for rhabdo was comparable, though, however, to African Americans who are using tobacco or having a high BMI. But certainly the relationship with an increased risk for rhabdo was clearly documented in this study that we published in, again, New England Journal of Medicine. Now, 2 papers as a sports medicine fellow that you just have to have read, hopefully, are these 2. The first is by Kark. This was in New England Journal of Medicine in 1987. It's a classic military study, large cohort, almost 500,000 military recruits. And he demonstrated that in that first year of service, if you're African-American sickle cell trait positive, you had 30 times the relative risk of sudden death as compared to African-American sickle cell trait negative. Kim Harmon, our colleague and a past president also of AMSSM, similar work, taking a look at the NCAA cohort here, looking at deaths between 2004 and 2008. And Kim concluded, comparably to the military, D1 football players alone, sickle cell trait African Americans, absolute risk of 100 to 805, 37 times risk relative to those who were sickle cell trait negative. So Kim's data really paralleled the data from Kark that this relative risk of death in those with sickle cell trait in African Americans exposed to exertion is real. Now, this is another great researcher in the area. His name is Dr. Philippe Pons. He's from Guadalupe, and he's done a lot of work on sickle cell trait, looking at hemorrheology and how things mechanically flow and how this may contribute. This was one interesting study. He looked at 8 sickle cell trait carriers and 8 controls, performed an exercise test, and he took like a blood viscosity, plasma viscosity, hematocrit, and red blood cell rigidity at rest, during exercise, and recovery. And what did he find? He found that there was higher red blood cell rigidity as well as viscosity in sickle cell trait carriers at rest and in exercise, and postulated this might constitute a risk factor for microcirculatory complications. Again, Kahns and his group have looked at the hemorrheology associated not only just with exercise and sickle cell trait, but those with sickle cell trait and alpha thalassemia. As I mentioned, Randy Eichner talked about this as a lifesaver, and Kahns actually demonstrated in this in the lab. Here he had 6 athletes with hemoglobin AS, sickle cell trait, 7 athletes with sickle cell trait and alpha thalassemia, did comparable work looking at blood viscosity, plasma viscosity, hematocrit, et cetera. And what he found was that RBC rigidity was again higher in the sickle cell trait group compared with the normal group, as well as those with sickle alpha thal. So he validated in the lab, in hemorrheology settings, that alpha thalassemia did indeed make a difference in the microcirculation, and perhaps the mechanism on why it's a lifesaver. Okay, what don't we know about sickle cell trait and exercise? Well, one of the things is trying to understand sickle cell trait and this increased risk for rhabdo and sudden death. What is the cofactor that makes the difference? Well, John Karp, in his work, in his cohort of about 500,000 trainees, really felt that heat seemed to be a cofactor in everything that he studied. Dr. Philippe Kahns, in his work, really believes that it's dehydration that contributes, and that if somehow we can normalize the hydration status and the hemorrheology and the mechanics of the blood flow, that we can make a difference. Randy Eichner, who has studied this probably more than anyone on the planet, as his comment I'm going to take right out of Current Sports Medicine Reports, heat is no more of a trigger for exertional sickling than is altitude, asthma, heedless failure, or a reckless coach, really believing the problem is intensity. And that is by far and away, in his assessment, the leading cofactor for some of these complications that we see. Now, this is one paper that was published in the British Journal of Sports Medicine 2012. But I think it's very interesting when you take a look at Loosemore, and he's looking at a postulated mechanism on what might be happening in creating some of these rhabdos and some of these fulminant rhabdos that may lead to death and arrhythmias. We've got exercise with a direct effect. We've got some of the indirect effects here taking place as well that might be impacting. But all these factors lead to a perfect storm: local hypoxia, acidosis, increased temperature, RBC dehydration, that may contribute that hemoglobin S affected cell may sickle and cause downstream effects. And with that cellular death, we may have ischemia leading to a fulminant rhabdo, or we may have cell death that may lead to potassium leak that may trigger an arrhythmia. But again, this is something we postulate. Now, one of the real issues here is that at this point in time, we do not have a pathognomonic autopsy that really nails it to say that it was sickle cell trait that caused the death. So this was published in Journal of Forensic Science back in 2001. There have been several other authors that have looked at this as well. But at this point, 2021, it still remains controversial as whether the pathogenesis of these exercise-related deaths involves microvascular obstruction by sickle cell erythrocytes. You really need a pathologist that has an understanding of sickle cell trait to try to piece this all together. But it's not a slam dunk. Okay, I think as a fellow, you should at least be aware of some of the issues with screening. Million-dollar questions that have faced the military, particularly the Army. You know, should an individual know whether or not they're positive or negative? And then, of course, the issue becomes not just the individual, but should the university or should the Department of Defense know your genetic status of sickle cell trait? You know, is there value to changing a sickle cell trait athlete or warfighter's training that we might mitigate that risk, that relative risk? Is there value for the medical team, for me to know knowledge ahead of time? No, or, and this is the controversy we struggle with, is knowing someone is sickle cell trait positive, do we potentially do harm to that individual through fear, stigma, or discrimination? So I think everybody now in 2021, flat out, you need to know your status. Sickle cell trait positive or negative. You know, there are genetic consequences to future childbearing. Everyone should know. And of course, everybody knows that across the United States, at this point, all 50 states screen for sickle cell disease and sickle cell trait. It is amazing to me, however, when I talk to individuals, how many of them have no idea that at birth that they were sickle cell trait positive. It's a surprise when they find out in college or military service. Now, this has drawn some interest as well. There's a great study by Trini, who took a look at sickle cell trait screening and some of the reassurance we get from it. But this is very interesting. She assumed here 100% effective intervention, that we could actually prevent these deaths if we knew. And she estimated here that you would need to screen 144,000 athletes to prevent one death. And that's assuming test parameters of the sickle cell solubility test, 99% sensitivity, 100% specificity. And if you screen the 144,000 people, you have to bear in mind, you are going to misidentify 22 people as negative for sickle cell trait, when in reality they were. So we certainly have always the limitations of the test. What about the NCAA and the Department of Defense? Should they know about sickle cell trait status. Well, this is pretty clear right now, Division 1, 2, and 3. 2010, everybody is required to undergo sickle cell trait screening. This is a result of a settlement with the Del Lloyd case, but you should be aware that while we screen, there are some people who are not very happy about this, in particular, the American Society of Hematology. They opposed mandatory screening at that point in time. They felt that that screening may have the potential to harm student athletes with bias and the larger community of individuals with sickle cell trait. So they took issue with it and felt that the better strategy was going to be universal precautions. So the next question is there value for the medical team to have knowledge ahead of time that that athlete's sickle cell trait positive? Can I make a difference? Well, we think so at this point in time. You know, theoretically, if an athlete has a fulminant rhabdo and you knew that he or she was sickle cell trait positive, you may be able to intervene earlier with the proper intervention and make a difference in saving a life or preventing a complication. Now, one of our fellows, Ben Buchanan, who's now in practice working with Kim Harmon, took a look at the intervention that was done in the NCAA, and we compared the death rate in African-American D1 football players before legislation and the death rate after legislation. And Kim and Ben Buchanan actually found that there was an 89% risk reduction after legislation was enacted. This is potentially a real game changer, validating that screening in the NCAA made a difference in the target death rate of D1 football players. Now, they went on to not only say did they have this decrement in the death rate, but they weren't sure if this was related to the screening or education or a combination of both. The last question is, how do you identify people? How do you mark them that they are sickle cell trait positive so that a medic or an ATC may know? This is something we're still struggling with. In the military, we are playing with ideas such as marking it on a dog tag so that if someone were collapsed, that a medic would immediately know that someone were sickle cell trait positive, but this is a question that is still being studied. All right, now, ASH, the American Society of Hematology, and others always fell back on this concept of universal precautions. And they fell back on universal precautions because that was the strategy for the Army up until 2021, that we used universal precautions, we did not screen. And the reason we did that is because of this information, this graphic I'm going to show you right now. And that is that the Army was going to make policy on absolute risk and not relative risk. Now, this represents here two pictures. We have the total enlisted population in fiscal year 9. And you take a look at it, it's a little over 500,000, and you had about 441,000 not African Americans, 108,000 African Americans, and inside that cohort, estimated 10% being sickle cell trait positive. Now, what we know is that there's a baseline background noise of non-traumatic sudden death. We also know the relative risk from Kark's work is going to be higher. So what we knew is that with sickle cell trait, 2.5 recruits per year would succumb to a sickle cell trait related associated death. We also knew, however, that the remainder of the cohort also was going to account for about 2.5 deaths per year. So looking at that, a lot of the leadership at that time said, well, you know, the relative risk is greater, but the absolute risk is comparable. And the strategy was, let's just see if we can use universal precautions for all and try to mitigate and prevent these sudden deaths. But this was the strategy the Army employed through 2020. Now, this introduced a very important concept in the military. It's the Einstellung effect. And that is that part of the strategy was to keep everybody's eyes wide open, and that anyone who would collapse, we would address them, that it could be a cardiac, could be a sickle cell trait, and treat them that way. Oftentimes I've heard that people will focus in on only those people who may have sickle cell trait. Or if it's heat season, you only think heat, you know, but avoiding being tunnel visioned. The Einstellung effect here, when prior knowledge harms performance. So it's a strategy to be aware of, but your eyes need to be wide open as you're looking at those athletes that might be marked with sickle cell trait, to remember that the rest of the cohort has a risk as well, and that those people with sickle cell trait can still die of hypertrophic cardiomyopathy. So your eyes have to be wide open. Bottom line up front, with a lot of the work we have done, the Army did roll out sickle cell trait screening. This actually commenced in November, December of 2020, and we're in that process right now. The Army no further ahead than the Navy or the Air Force and no further behind. All right, what is exercise collapse associated with sickle cell trait? Well, again, we introduced this term in 2011. We knew at that time that exercise death is real, but most of these cases are relatively rare. Most of the profile is drawn from case reports. We know that most of the deaths are in people who are underconditioned or deconditioned, being pushed at a particularly vulnerable time, whether it's pre-season or basic training or during a PT test. Tended to have a greater incidence with repeated intense exercise bouts that you might see in a football player running serial sprints where they have limited time to recover. And one of the most striking things is that it's unusual muscle weakness, highlight weakness, pain or cramping, and in general, it's a conscious collapse, at least initially, before the athlete becomes obtunded. So it's very different than that whack of a heat stroke collapse or the face plant of someone who has a sudden cardiac arrest from a hypertrophic cardiomyopathy. So we published that, we identified describing sickle cell trait collapse, and I've got this in the literature. I'm not going to belabor it at this point. This was published in 2012. Now, as I mentioned before, 2019 was a tough year for the military. Both the Navy had some issues with sickle cell trait related collapses. We also see here one article occurred in the Air Force Times. Shaw suspends PT test after 2 airmen's running related deaths thought to again be associated with sickle cell trait. And this raised the question again. So we brought the band back together literally to discuss ECAST and come up with a better way ahead. This is Major General Talita Crossland, family physician, Deputy Surgeon General of the United States Army, who was one of our keynote speakers as we tried to get our arms around this and come up with a way ahead. And this became actually the generating conference and document on why the Army now screens. So I want to walk you through this video on what is a sickle cell trait related collapse. It's a real individual here who spoke at our conference that helped drive the dialogue.
While sickle cell trait is largely benign, it can be associated with significant complications to include exertional rhabdomyolysis or severe muscle breakdown, or the rare entity of exertional sudden death. What is exercise collapse associated with sickle cell trait, or ECAST? Most of these collapses or deaths are described in either athletes in preseason, military recruits in basic training, or warfighters participating in physical fitness tests. The collapses or deaths are associated with marked strenuous exercise. The case reports also describe that not only is this exercise extremely strenuous, but there is frequently evidence of repeated high-intensity drills with limited periods for recovery. Additionally, not uncommonly observed is seeing someone who is struggling to catch their breath well beyond what is normally experienced. These collapses are also unique and unusual in that they are associated with marked muscle weakness, pain, or cramping. In addition, many of these collapses are observed as occurring in individuals who are initially conscious. This means that the affected individuals are not stopped by a loss of consciousness, but by marked weakness or pain. This creates a unique opportunity to intervene and potentially save a life in someone who may be in trouble. What does an ECAST or exercise collapse associated with sickle cell trait look like? I would like to now introduce you to Mr. Clifford Melton. Mr. Melton suffered an ECAST event several years ago during a team competition as part of a personal security detachment. He was in excellent physical condition and well trained for the event he was to participate in. The event resulted in severe muscle breakdown requiring surgery in his legs to relieve pressure and to ultimately save his life. You're going to observe him talk through what he was feeling and experiencing during this ECAST event. Importantly, before you see him running and shooting, he actually carried a 180-pound dummy body up 5 flights of stairs to simulate a rescue. While he was well trained for this carry procedure, he had limited time to catch his breath during this competition. You were at the far shooting lane.
Yes, and I got there. It was an actual open box with a mouse board. I had to shoot all over prone. And I had 3 targets. And I had a cliff sight picture, pressed the trigger on my first target, knocked it down, saw it go down. Tried to re-engage second target. Everything went black. I couldn't see.
You went black, but were you still with it?
I was still hearing everything.
You were hearing everything.
I was hearing everything. I could hear gunshots. I was very conscious.
So were you able to get up on your own?
Oh, yes.
How are your legs doing at this point in time?
They were very heavy.
Heavy legs.
Heavy legs. Still feeling the same tightness I felt.
Still 7 out of 10?
Still about a 7 out of 10.
So you're running back down to an ammo point?
At that point. And you can probably hear somebody audible just saying something. And it says, "Come on, Cliff, move." I remember that. And I remember speaking in my gas mask. And I'm telling you, I almost felt like crying in my gas mask. I said, I'm trying.
Okay. Tell us here. So you're going to be coming from the left side of the screen. If you can describe what's happening.
I'm trying to keep going, just trying to push myself out. It's like my body is pretty much giving out. And right here, this is when coach is still trying to motivate me to keep going.
All right. So your teammates are helping you here.
Yes,
they're carrying you. And I understand this is tough to watch. But your teammates are watching, so we'll pick it up if you can describe it for us, Mr. Bell.
They told us that I had to get to that shooting box or we would get disqualified as a team. I just felt like I want some water at this point. I wanted something. If you really take a detailed look at my face, you probably can see the flushes. Kind of like I felt like I was swollen. Legs were tight. I could not move them. You know how you just sound like you're trying to drive your hips forward. I could not at this point. At that point right here, I was done. I was done. But I'm still coherent, knowing what's going on. I'm still thinking, hey, I still can get up here and shoot. Thinking I'm in the fight. And I'm telling you, that is where dizzy, my head is, I'm hearing everything.
What do you think of the important clues for that young warfighter with sickle cell trait to be aware of that's different?
When you start feeling that pain in your legs, it's something that you normally don't feel. You need to pay attention to that. You need to pay attention to your breathing. You have probably been running all your life, and you know what it feels like to overexert. You know how to slow your pace down. But as you get to the point where you cannot control that part of it, and you have leg pains, you may be going through a medical crisis.
Okay. Let's talk about the team and the cadre who are watching the team. What message would you have for them as they watch this?
I know they're trained, or you're trained to be tough. And don't look at your teammate or your soldiers that's next to you as being weak or being, you may want to look at the medical side of things first. Kind of need to know who walks beside me.
Well,
I think that was one of the most important things he said was you need to know who walks beside you. And just so many great teaching points in that case. He needed fasciotomies, upper leg and lower leg, went to the OR several times. Had a CK in excess of 500,000. It was a dramatic fulminant collapse, but he fortunately lived. So let's talk about management of ECAST. One of the things we do right now in the United States military is all new recruits watch that video. It's a 13-minute video where we talk about sickle cell trait, but we really emphasize the message that the great majority of people with sickle cell trait can serve and they'll have no complication, but they need to be aware of potential problems. As a team physician, you should be aware of the NCAA guidance, and I would call your attention out to this. It's a very simple concept, engage in slow and gradual preseason conditioning. It's all about exercise acclimatization. And that's a strategy we use in the military. It's a strategy that should be used in athletes. And that's what protects people. Primary prevention, I'm going to turn to Dr. Philippe Kahns again. Hydration is critical. He's demonstrated in this lab with hemorrheology, believes that ad libitum access to hydration can help normalize some of that viscosity changes, the blood hyperviscosity, and this is a powerful primary intervention for those individuals with sickle cell trait. Secondary prevention, Kim Harmon, John Dresner, Doug Casa have published extensively on things to mitigate sudden death. But bottom line up front, I think for the military and for athletes is recognize people who are struggling, and we should never use exercise as punishment. These are some of the most important strategies, both primary and secondary, but recognizing someone who's struggling and not dragging them across the finish line or said, get up and finish. They need medical attention. Tertiary prevention, now they're in the throes of a sickle cell trait related collapse. We've published on this in our most recent paper. I'm not going to belabor everything. I'm going to outline it for you in the essence of time, but most people believe at this point that the early provision of oxygen can make a difference. We have published in 2021 in Current Sports Medicine Reports an initial management algorithm. We're using this in the military right now on trying to train our medics on how to think through exercise-associated collapse and recognize that ECAST event, provide early oxygen, watch and see what unfolds, and then execute something that many of you be familiar with the NCAA guidance is getting them to an emergency room to have the team there be prepared for a potential metabolic storm. Oxygen. So here you actually see up at Naval Air Station up in Newport, this is a medic, and the medics now who are out there supervising exercise not only have an AED, but they have oxygen canister right there as well. So when our recruits are training, and I actually watched them go through a mock sickle cell trait collapse here at Newport, they're ready to go for any kind of collapse. Big issue for us is also who can return to duty, who can return to play, who should go home to mom. We believe that in the absence of a non-modifiable risk factor, that these people should be re-exercised, acclimatized, and reintroduced into activity, and that's what we're leveraging right now. Again, this is published in Current Sports Medicine Reports, so I won't belabor it at this point. But these are all questions that we're working through at this point. This is our swag at this point on what we think we should do, and we're trying to follow these people forward. Where do we go from here? Well, we're very interested in this, CHAMP, at this point in time, studying this. We've published over the years on this a number of different publications. I mentioned the New England Journal article. We've looked at renal disease associated and its risk factor, how that may contribute, the percentage of hemoglobin S and fitness levels we've studied. We've looked at heat as a risk factor. Wrote an interesting article with Chad Asplin on thinking through return to duty, return to play on sickle cell trait, which is a tough call once again, and again, the paper we just published in 2021. The fascinating thing to me as a researcher in this area is that I know in the military, I know the death rate, the absolute, the relative risk, but that's always been the interesting thing to me. We got recruits, the risk of sudden death is 1 in 3,000. So I have 3,000 recruits with sickle cell trait. One is going to die. I'm always wondering, why not all 3,000? Why didn't they all die? Why just the one? Is it an extrinsic risk factor? Is it intrinsic? Trying to piece this all together, because most people in the military are going to be under a similar load. So we are studying this in terms of the genomics and would there be an associated gene that might contribute to the risk factor? But at this point in time, that genomic research is a long way off. I believe that not all athletes may be the same, but the strategies should still be looking at intensity, universal precaution, screening, and education in the absence of this research. This is our study that's up and running right now with the NIH as we're trying to study these collapses and come up with some of these answers. And again, bottom line, it's exciting, promising, but it's exploratory. One of the things we are doing with the NIH right now with returning people to duty is exploring some interesting phenomena with the hemorrheology with sickle cell trait, literally putting someone's red blood cells through an exercise stress test. So as you can see here, literally putting them through a stress test. This is a lab over at the NIH right now where they'll take red blood cells, subject them to lower rates of oxygenation over time and look to see the percentage of cells that sickle. So this is not only genotype, but phenotypic expression, because some people with sickle cell trait act more like people with sickle cell disease. And I believe that this profile someday may help me make a better decision on who should go back to the military, who should not go. This is a website we have up and running right now called the WEC, the Warrior Heat and Exertion-Related Illness Collaborative. We're studying sickle cell trait, exertional rhabdo, as well as heat stroke, and trying to make a difference in these areas. Again, this is what our website looks like. We have an Ask the Expert function and try to answer questions for DoD, but I'm out there to help anybody think through this. As I said, I have many more questions and answers. I do believe in the end, though, like Randy Eichner, that in the critical variable, and probably most important, is going to be leadership. Whether it's the coach, the trainer, the drill sergeant, this is a critical factor. Most people will self-regulate, but under the pressure of a leader, this may push people beyond that physiology. Scott Anderson, who's worked with Randy Eichner, has published on this recently. And bottom line, with excess deaths, non-traumatic exertional fatalities, most of these occur during training, coach supervised training sessions. That's not on the game field. So this is an important variable we need to pay attention to. So here in my conclusion, this is a common problem. You should be aware of the issue, how to recognize an ECAST, and my bottom line up front, there's a lot more work to do in this area. So with that, Julie, I'm going to stop my share and turn it back over to you. Thanks, Julie.
Great, thank you, sir. So as we wait for some questions to roll in, I'll get you started with one. And I don't know if there's a right answer for this, but wondering what your thought would be for those of us going to work out with sports teams, how we work to start changing that culture, that competitive push through the pain culture that is often surrounded by a team, whether on the playing field or the battlefield. Starting with the top, but what methods might work best to change that culture?
Yeah, that's a great question, Julie. And as you know, this is something very interesting for us in the military. We created that 13-minute video for soldiers who were diagnosed with sickle cell trait. It's used at Great Lakes, Lackland, Julie's in the Air Force, and at the Army post right now. But I've gotten some feedback from people with sickle cell trait saying, hey, Dr. O'Connor, this is great. I enjoyed it. I learned a lot. And again, our message is very positive. It's not all that collapse. But they all came back to me and they said one thing, Julie said, it's not us that needs to watch it. It's the coaches. It's the trainers. It's the drill sergeants. It's the leaders. So I think, Julie, when you're out there at a college, you're out there in the military, the focus on education is not just to the athletes who are sickle cell trait positive, but it's to the leaders. So that would be my first strategy, Julie, is educating a broad cohort. Over.
Great. Another question I have would just be, you discussed both the kind of adverse effect of sickle cell trait being inability to concentrate urine, but then also dehydration as being perhaps a precursor to sickle-related events. Has there been any studies that have demonstrated looking at specific gravity or another marker of urine concentration might predict when a sickle-related event could happen?
I think it's a great question, Julie. You know, there's a researcher up at Johns Hopkins, Dr. Rocky, I believe, and she's looked at kidney disease and sickle cell trait and these prediction factors. And I know that a lot of my sports medicine colleagues will check urine-specific gravities to ensure people have recovered. But this is a gap area, Julie. This is something that needs to be studied. Certainly the logical sense is that if you have hypoosmolarity and you can't concentrate your urine, that you're going to have a greater risk for dehydration and trouble with exercise. So to me, it makes sense, but it's something that I believe needs to be studied. I will say, Julie, as we're evaluating recruits, that if you've shown me 1 or 2 sickle cell trait related collapses, and we do have a study looking to see if you're hypoosmonuric, I'm probably going to recommend that that person is cut. You know, certainly if you've demonstrated 2. So it's one of the things that I'm going to look at if someone's had problems. One thing if they're on your team at the college, but in the military, you know, if you show me 1 or 2 episodes in your hypoosmonuria, I'm going to recommend that you probably go back home.
Great. One of the questions we have is from someone who has been working with Kaiser for a while, but just curious if there is a registry for the DoD and sickle cell trait related collapse and or deaths.
That is Dr. Darlene Smallman, who I know very well. And Darlene, I actually have a meeting next Wednesday. We have been fighting, Darlene, to set up a registry here on exertional death to include not only sickle cell trait, heat, rhabdomyolysis, sudden death. So no, the answer is no, there's not. But we're fighting for that, Darlene, to try to get a better handle on this. As you know, Darlene, you look at these deaths at Great Lakes and at Shaw Air Force Base and others, a lot of controversy. What caused that death? Was it a sickle cell trait related death? Was it something else? I think a registry, Darlene, is going to be critical for us moving forward, and it's a gap right now. Over.
Wonderful. Well, those appear to be all of the questions that we have that have come through. So thank you so much for your wonderful lecture today and teaching us all about what we do and don't know regarding sickle cell trait. And so I guess for now we'll sign off.
Okay. Thank you. Talk to you later, Julie.
Bye.